Hello and welcome. Now this is a real gas dynamics problem. We have air entering at 250 degrees Celsius and 300 kPa at, we'll call it state 1 right here. And the velocity is also supplied 50 meters per second. And the exit Mach number is 2. Obviously it has to be in the diverging section, and we are calling it state 2 here. And the Mach number is given here as 2, and also the area is given 10 centimeters square. Therefore, this state can be fully evaluated. Also, it's isentropic flow because its Mach number is 2, no shock wave anywhere. So therefore, we can use that the total temperature remains constant because of the energy equation. Total pressure remains constant because of entropy remaining the same and isentropic flow. And of course, critical area remains the same, S star remains the same. That's because of the consequence of mass conservation. We are also asked to determine the throat area. We call it state 3. Of course, throat area would be identified by Mach number 1. And then the Mach number in somewhere in the diverging section where the area happens to be 8 centimeters square. We designate that as state 4. Well, I have already calculated state 1, 2, and 3. And then we'll do state 4 together. So let's first go and show you, let me show you what I have done so far. So state 1 is everything given to us here. So it's very simple. Pressure is given, temperature is given, and not everything, but at least, and the velocity is given. So we can find all the total properties, total temperature, total pressure, etc. However, we cannot find S star because we don't know the area. So inlet properties are given. So we cannot find the mass flow rate based on these properties. Inlet area is not supplied to us. We could find it after the fact because if we do the exit state, which is state 2, Mach number is given to us. So let's go and take a look what is given here. Oops, let me erase this marker first and put some new marks. Mach number is given at the exit state, the very exit state. And we know that total temperature will be the same, total pressure will be the same, and also the area is supplied to us. Therefore, the complete state is known, producing the mass flow rate that we have been looking for. If the question was find the inlet area, we could go to state 1 back and substitute S star 1 equals S star 2 because that's the mass conservation equation. That's a gas dynamics way of saying m dot 1 equals m dot 2. Okay. But that's not the question. So the next question is we want to address is what is the throat area? So for that we do know at the throat Mach number equals 1. That's one condition. Again, the energy equation gives us total temperature and entropy equation gives us total pressure being the same. And the mass conservation tells us that S star must be equals S star 2. Therefore, the throat area is now found. It's 5.9 centimeters square. The final question is, what is the Mach number when the area is 8 centimeters square? The reason I want to solve it together is that it's a little bit complicated thing to solve in a gas dynamics app. Because think of it. Let's just first enter the numbers given, 8 centimeters square. We know the temperature, total temperature will remain the same, total pressure will remain the same, and S star will remain the same, which is A star. 1 is not known, so 2 is known. I'll put 2. But look, when I calculate, what we found is a Mach number of less than 1. And the reason becomes obvious. Look, the area that we chose, 8 centimeters square, is bigger than the throat area. But how in the world this state will know that whether we are talking about the converging side of the duct or the diverging side of the duct? The area might be 8 centimeters square on this side and on this side of the duct if this is our critical area or the throat area. So in other words, we haven't specified where I am. Am I in the diverging section or converging section? We have identified the location with variables. The temperature, total temperature and total pressure remains constant. S star remains constant. This is just mass, energy, and entropy equation. That's true for anywhere in an isentropic flow. Anywhere along an isentropic flow. The only extra thing we said is that the area is 8, whereas the throat area is 5 point something. And area 8 could be on this side and on that side. So that's why in this case what happens when you calculate the state, um, it does come with a message at the bottom that it says there are two solutions. Mach 1.713 is the supersonic solution. In other words, we are looking for the supersonic solution. So what we'll do here is that now that we know 1.713 is our Mach number on the supersonic side, so we'll take one variable off, suppose the area we don't know, we'll say, and we'll specify the Mach number 1.731. And now if I do a calculate, notice, I don't think I picked up the Mach number exactly, but it would be very close to 8 centimeters square. The area will be calculated correctly. So whenever there are two solutions involved, you've got to be always watching out for a second solution for the Mach number at the bottom of the screen.